a big problem that we see in the market right now is that nobody really likes state machines. And I'd love to do a little poll on that. So how many developers are here from bots? Cool. And how many of you like state machines? Just like leave your, okay, great. I hope I'm going to convince you that they are not good in this talk. But yeah, I'll talk more about why it is like that. But maybe just really briefly, Alex, my name, co-founder and CEO of RASA. We are building open source tools for developers. Pretty much the first product that we launched 9 months ago is called RASA NLU. It does intent and entity classification, has now over 20,000 developers using it worldwide, including like large enterprises, but also like bot startups. And the really exciting thing for us is as well that universities started to pick it up and actually do research with it and then also commit stuff back. So that's really exciting because overall our thesis is that despite all the hype and all the conferences and all the talk, this whole field is still very early days, and we also believe that there need to be many, many more technology advancements to actually really converse with a machine in a way that we are used to with humans. So that's where we come from. And where we actually come from is that my co-founder and I, 2 years ago, started hacking around with a bunch of tools and built a bunch of bots. And what we fairly quickly realized is that NLU or NLP in the classical sense is really not enough to build intelligent systems. And so why is it not enough? I brought an example. So this is actually from one of our customers, a bank. And let's imagine you have a conversation with your bank and you want to know like which savings account that they just proposed to you actually has the highest interest rate. Pretty simple question for a human. If you're a developer in the first place, you never build a bot or you haven't really thought about it much, you would probably think that this is how people ask this question. So they say like, which savings account has the best interest rate? And then the bot just pulls up some answer. You have like Super Saver and Deluxe, and that's pretty cool and straightforward. Unfortunately, as we all know, humans don't talk like this because they usually take context into consideration. And in this case, if I ask before, like, what different saving accounts do you actually offer? I get like 2 options, and then I ask something like, which of those has a better interest rate? You already need to take the state of this conversation into consideration because you cannot just map it as a simple question and answer pair anymore, because you might not know if they refer to, in this case, savings accounts, or they might refer to a mortgage or something else. So, you know, as we know, stateful systems or stateless systems are fun, depending on that. I like this quote. It was a tweet. It was deleted. I don't know why, but we sort of saved it. And I love stateless systems. Don't they have drawbacks? Don't what have drawbacks? So classical problem as a developer, how do you build a system that can actually keep state and make sure that you know what has been talked about before in this case? And that's really a pain in the ass to build. So how can you build it? Pretty much 2 very different approaches. If you look into like what bot developers use right now, and I'm gonna go into detail, it's a very like rule-based approach. So you figure out like what the flow could be like, you anticipate what users can say and what not, and then you pretty much have a flow chart like on the left. If you look into academia, there are a lot of approaches that are entirely data-driven, and I'll also talk about more how they actually look like, but they are really not having any rules, right? So you can get to some pretty impressive conversations with that, which is quite cool, but doesn't really lead anywhere. So let's take a closer look on what most developers do right now. So I said like state machines earlier, and this is like how a state machine could look like for the case that I just described. So we again, like in banking, you have an initial state where you don't know anything about the user or about the conversation, and then as soon as he says something like, you know, what different saving accounts do you have, you actually go into a state. In this case, it's the savings search, and then you know that this is the context. So if in this context I ask something like, which of this has like the highest interest rate, I would know that I'm in this state, so I would know which answer to give, right? So that's kind of logical. And that's sort of the obvious solution to this. You can also nest that with a lot of if and else statements, which is also not much fun. But in any case, this is like the rule-based approach. So what's the problem with this? That doesn't really scale well. And I asked that question earlier because I think most people who build a state machine with a bit of a more complex bot or assistant know that this is really hard to scale. Because pretty much as soon as you have something that strays away from the happy path that you've thought about initially, so in this case, if I give like 2 options, but then the user actually says, what about option 3? This is like an edge case you need to handle, because otherwise it's a very dumb system. So how do you handle it? You have like another state, or you have another if and else statement. So you have an edge case of an edge case of an edge case, and it's just like increasingly getting very complex. Is that like, yeah, I see a lot, okay. Yeah, so that's pretty much also what we've seen 2 years ago when we started building bots. And when you look then into academia, you have like 2 different approaches to solve this problem. The first one is this like almost like a chit-chat system. Who of you here has seen this movie, I think 7-minute movie that was created by an AI a year ago? Has anyone seen that? Yeah. So what they did there is pretty much they fed into a deep neural net some movie scripts, and then the system generated like a 7-minute script out of it. I think it was actually started by one of the guys who was playing in Silicon Valley. So they just like had this 7-minute movie, and it sounded like a real movie, but it didn't lead anywhere. So there was no like, no sense in it actually. It sounded like a movie. And that's pretty much what a chit-chat system in this case does. It sounds very natural. Uses like sequence-to-sequence models. In this case, you have something like, what do you think about Messi? The machine says he's a great player. So, sounds pretty accurate. Great football player, Messi. The problem is that it's really just like for like conversations that are almost like small talk. So this is an important piece for sure. So it's not like totally irrelevant, but it doesn't really help you if you want to, get a new savings account, for example. So other approaches to these are task-oriented dialogue systems. I'm not sure if anyone of you has played around with these. There's been a lot of research on that recently. And what they do is pretty much, they take a whole conversation into account and then optimize with reinforcement learning. So what that means, let's say you have a problem like restaurant search, so you want to find the best restaurant in San Francisco. In this case, you start the conversation, and then in the end, you get a reward if you really found the right restaurant. This sounds really cool, and is definitely the future, how these systems will be built. The problem is just that you need a lot of training data for that. So it's like, even if you're a large bank, you probably don't have enough training data for something like this. So this is like more the future. Also, the problem is, like in this case, it actually has a generative network. I think there was a talk earlier on stuff like that, which really like generates the responses as well, which is something that you might not want in any case. So like both approaches don't really work, at least in reality. So what we call that is like pretty much like from papers to products, because if you work like with large enterprises or like bot builders or whoever, you have different realities. And the first one is that really there is a big white space between all these like archive papers and sort of the enterprise environment. So what does that mean? As I already said, even large companies, they have a lot of data, but they don't have, at least from our experience, not a lot of high quality data. So what does that mean? It actually means like data that is like relevant for the products that you want to sell, but also like training data that actually goes like multi-turn. Something like that is a big problem, so you don't have like gazillions of these. So you need an approach that can start without data actually. The other problem, from our experience, even a bigger problem, you really have a lot of like legacy code and a lot of legacy databases you need to access, which also means that data might, you might think of it as like your customer data, but then it's like in 20 different databases if you're like Bank of America or somebody like that. So how can you make sure that you can access that as well? And then the last one, and I said that earlier, so it's really cool to have an only data-driven approach, but then mostly you have some sort of business rules that you want to weave into your conversations. So for example, if you are like a life insurance company, you're actually liable on what type of life insurance you suggest to somebody. So you need to make sure that you can track why certain decisions have been taken. And if you only use a data-driven approach, that doesn't work, because you can't really look into a deep neural net. It's a whole research problem. So you must follow some rules in this case. And that's pretty much the RASA way. So I said earlier, like we have this product called RASA NLU. So that does like intended entity extraction. And we have a new product coming up, which is called RASA Core. And then you can throw away your state machine. And if you guys know Rage Against the Machine, anyone has a personal connection to them, please let us know, because we want to get them for our launch. Rage Against the State Machine. And how does it work? So you have like NLU, as I said earlier, which turns like pretty much unstructured text into structured data, intents and entities. And then you have RASA Core, which is in pretty much dialogue engine that predicts what should happen next. But the way how this works is not with a reinforcement approach. We actually have that in the pipeline as well. But we found that you want to start somehow the way how you used to start, with like a happy path, right? So you want to figure out what could be the turns of this conversation. But then on top of that, you want to make sure that you can adjust for unhappy paths in the future. So how does it work? Yeah, with a lot of not so sexy interfaces right now, but we're working on that. But pretty much on the left side, you see a markdown of like the happy path. So pretty much what you would model in a state machine initially. So you come up with like stories, we call that, how a conversation could go. And then an action could be anything from like actually giving a response, but it could also be like doing an API call or like saving something to a database. And then as a second step, you use interactive learning in this case. And you have like pretty much somebody talking to your bot and then somebody else deciding if it was the right action the bot took or not. And if not, you can pick the right one or like add a new one. So that sounds a bit, uncool because it's not like automatically trained everything, but it actually works. And the cool thing is that it's almost like reinforcement learning, but more like on a like one like input and output action. So it's pretty much setting you up for all the cool things that you can do with reinforcement learning, but also takes into account that you might not have enough training data to start with. And that's RASA Core. We're going to launch that very soon. It will be open source as well. If you're interested, let me know. And if you guys are great engineers, we always look for great engineers based out of Berlin. And yeah, happy to take all your questions. Thank you.